Today we are going to discuss the topic about regulation of alternator. Voltage regulation. A voltage regulation of alternator is defined as changing the terminal voltage no load to full load divided by the full load voltage. Voltage regulation is equal to no load voltage minus full load voltage division of full load voltage is 100. So voltage regulation is equal to E naught minus V divided by V into 100. There are different methods available to determine the voltage regulation of alternator. Direct loading method, synchronous impedance EMF method, MMF method, Portier triangular method, American standard method, and two reaction theory. Direct loading method. The direct loading method circuit diagram is shown in figure. The star connected armature winding coupled to the three-phase load and prime mover is connected. Then the star connected armature to be connected to the three-phase load circuit. The field winding is excited by separate DC supply. To control the flux that is current through the field winding, a rheostat is inserted in the series of the field winding. The prime mover drives the alternator at its synchronous speed. E phase directly proportional to pi. Percentage of regulation is equal to E phase minus V phase divided by V phase into 100. For high capacity alternator, that much full load cannot be simulated directly connected to the alternator, hence method is restricted only for small capacity of alternators. Synchronous impedance method or EMF method. The EMF method circuit diagram is shown in figure. The method is also called EMF method. The method requires flowing data to calculate the regulation. The armature resistance per phase RA, open circuit characteristic and short circuit current. The open circuit characteristic, the graph of open circuit voltage against field current. This is possible to conducting open circuit test on the alternator and short circuit characteristics, which the graph short circuit current against the field current. This is possible to conducting short circuit test on the alternator. ZS is calculated and RA is measured and XX is obtained. For given armature current and power factor, E phase is determined. Regulation is calculated. The synchronous impedance formula is ZS equal to VOC phase IASC. ZS equal to phase EMF and open circuit divided by phase current short circuit. ZS equal to OD phase divided by OE ISC. Regulation calculation ZS equal to RA square plus XS the whole square. XS equal to ZS minus RA whole square. E phase equal to V phase cos phi plus IA RA square plus V phase I sin pi plus or minus IA XA the whole square. Percentage of regulation equal to E phase minus V phase divided by V phase into 100. Phasor diagram loaded of alternator unity power factor. Reference voltage V. OA is V phase. OA is V phase. And AB is IARA. And BC is IAXS. And AC is IAZS. And OC is E phase. Consider triangle. So OC square equal to Pythagoras theorem. OC square is equal to OB square plus BC square. So apply the values. E phase square OA plus AB square plus BC square. So formula is E phase equal to root of B phase plus IARA whole square plus IAXSC whole square. Next, lagging power factor phasor diagram. So lagging power factor phasor diagram, E phase equal to root of same but small changes. V phase cos pi plus Ia Ra square plus V phase sin pi plus Ia x square. Advantages of advantage. The main advantage of this method is synchronous impedance is a test for any load condition can be calculated. Regulation of alternator, any load condition and lower power factor can be determined. Actual load need not be connected to the alternator. This method can be used for very high capacitor alternator. Limitation of synchronous impedance method. The main limitation of these high values of presentation regulation than actual result. Hence, this method is called pessimistic method. Thank you.